Well, change of plans. It looks like I might have screwed up my rotator cuff, so now I have been at the moment told to not lift anything with my left hand heavier than a TV remote control. So time to work on some different projects, and this needs to get done anyway. What is in front of us here is one of the many boards that is in the video and servo system in the Ampex VR-1200, which is over in New Kensington, PA, over at Workshop 2, we will say. Now, I had noticed in having worked on that machine that there are a lot of tantalum capacitors, which would be these ones, these type of capacitors that are either completely open or a few that are shorted. The ones that are open have leaked their electrolyte onto the board through a failed seal. These are wet tantalums, and so they usually don't fail shorted, but they can. So just to give a quick check here, I've got the multimeter. Now this is not an ESR check. This is not an ESR tester, but this will get some basics. I mean, if it's shorted, it's shorted. It doesn't matter if it's going through an ESR tester or something that provides DC like the multimeter. A short is a short, and it's not going to be a short at DC and not at 50 kilohertz. So it gets you close for this kind of testing. For this kind of basic, want to replace it because it's shorted or open, that can be tested with a multimeter. So, just to do a quick spot check. And they are all going to read different because they are in circuit. But again, a lot of them are seeming to read about the same. Now these larger ones may actually read over what the yeah, this is a problem. This one is 130 ohms, so yeah, this one is almost a short, and it should not be. So that one will get definitely replaced. These big ones here will... that might be a problem. Yeah, 17K. Looks like this one is also 4.2K. 10 meg. Okay, that one seems to be a bit open as well. And then let's get this one. Yeah, so, okay, it was this one. And then I believe this one. Wow. Yeah, this one and this one. Those are going to be replaced on this board. This is the switcher logic board, so if this board is not working properly, the switcher as in switching between the video amplifiers. To switch the video amplifiers 1 through 4 in order to produce the video signal. So if this is not working properly, yeah, that's going to be a problem. So I'm going to remove this bracket, get it in the clamp here, and start removing capacitors. And I'm going to have to check the values and see what they are, and then get them replaced. So I've not yet removed the capacitors, but I wanted to let you know kind of what I do here on these boards that on the underside do not have any markings for what components they are. This is common on older boards like this, which is from '67, and you didn't get component designators on the underside of the board. Let me grab a newer board from the 80s or 90s and show you what I'm talking about. Yeah, one sec. You see, this is a board from the 90s, a Sony VTR, and if you look, you'll see that there are component designators, so you know exactly which ones to go after. That was not common practice in 1967, and even into the 70s and 80s. It depended on the manufacturer. Not all of them did component designators. I've put little marks, just Sharpie, and they will come off with the solder. This iron is not hot. It's not on. So then I'll remove the capacitors. I'll look and see what I have, because I don't know if I have all those capacitors. So I may get stymied by that, but might have to make some adjustments, because there are some strange ones in there, like non-polarized electrolytics and 1 microfarad, and those aren't used all that often, so I don't think I have any in stock. But a film cap that's 1 microfarad could also go in there, so we will see. Well, we'll do this again with me wearing the microphone, because that might just help. Another thing you will see on these earlier circuit boards, especially on boards for commercial broadcast and military use, is that you see here, again, not hot iron, but the leads are folded over. So the components are inserted, the leads are trimmed and folded over, or folded over and trimmed. Not sure what order they do that in, and then it is run through the wave solder bath. That was common, and it was thought to actually help the connection be a more stable connection at the time. That was then later found out to not really be necessary. So by the early 70s, but definitely by the mid 70s, that practice was done. It just makes things a little more interesting, because what you have to do is you have to unsolder and then come in with a pair of tweezers or real thin needle nose and bend things up while the solder's there, and while the pliers are trying to act as a heat sink to take the heat away from the solder. And that's just something that isn't done anymore, because it really isn't necessary. So from when they'll be replaced, they'll just be replaced normally. Leads stuck through and soldered. All right, so the caps have been removed here and here and here. So now I need to see what the values are. I know what one of the values is, and that's the 1 microfarad non-polarized, And the other here is a 10 microfarad, 20 volt. And then the other one, I can't read its markings, so I'm going to have to look it up on the schematic. I know I have the 10. I do not have 1 microfarad polarized, and I think I'm going to replace that with a film and remove its other brother that is on here, which is actually right there in the top. And I will get that one replaced as well, because that is a standard electrolytic, and those tend to fail. So I might have to order some caps here, but I'm going to go on to the next board, which is the amplifier board, and then also on to the, I think this is the switcher and equalizer board, and I'll go through each of those and do what is necessary, and then we'll go from there. Alright, so I have gotten 2 of the 3 capacitors in, the 10 microfarad and the 1 microfarad, which was this one, which the end came out of, and then this one. Those are both 10 ohms, and then there's this one, which is a 1 microfarad non-polarized. I do not have any of those, and I'm just going to replace it with a film. I don't have a 1 microfarad 50 volt film, but I am ordering some, because I do have 1 microfarad film, but they're 650 volt, and they are just a little bit too large for the area where they need to go. I mean, yeah, that's just a little too big. So I'll get some of those in, and I will probably also remove and replace this one, because if it's, the other one is already gone, this one is probably likely to go. They are all 1967 capacitors. So that's it for this board. I did put some heat shrink on this one because there are 2 traces that run underneath. And it's nice that new capacitors are much, much smaller. These are both 50 volt, and the originals were 20 volt. And these are both Nichicon, and they're both low ESR, high frequency, which is fine because this is switching and video amp, so that's a good thing. So that is it with the switcher logic board, and I'm going to go to the next board here. Here we have the video amplifier board. There are 4 exact circuits there to be each of the video amplifier channels, and went through and checked all the capacitors and found 2 bad ones, and they've both been replaced. They were both 1 microfarad at, I think they are 20 volts. Yeah, 1 at 20, and they were doing a very interesting thing that sometimes I've seen these capacitors do, which is to sit there and go open and short and open and short and open and short, and they would do it, and yeah, that's gonna mess with the video signal. So I just replaced them. The other 2 were okay, and that should be it on this board, at least for the moment. As I go to use the machine, I do understand that things are going to change and that other components will go bad. Now, I did also check on the equalizer board here and did not find any bad capacitors, so it got left alone. And then this one I'm just going to reassemble, put the handle back on, and then it should be good. And then I will throw it in the machine when I go up to Pittsburgh next and see what that does. I'm sure there are other issues because there were lots of boards in that machine, 84 in total, and it had been sitting dormant since about 1981. So every time I power it up, it's going to, I try to leave it running for at least 25 minutes to a half an hour to warm up fully, but that is going to cause other components that are marginal to fail. And okay, I'll let you know what happens when I do that.